So you can see this problem in your practice problem in week 3, which is basically your number 6. So this is the solution of this number 6 problem. So a car is to be hoisted by elevator to the 4th floor of a parking garage, which is 48 feet above the ground. If the elevator can accelerate at 0.6 feet per second square and decelerate at 0.3 feet per second squared and reach a maximum speed of 8 feet per second, determine the shortest time to make the lift starting from rest and ending at rest. Okay, the, the keyword here are starting from rest, ending at rest, decelerate, and accelerate. These are the keywords that would give you the clue in solving this problem. So, but first, let us uh, draw the free body diagram of this problem. Okay, so take note that the body will be the elevator or this will be the particle. It is going an acceleration upward, which is equal to 0.6 feet per second square at acceleration, and at deceleration it has uh, average acceleration of 0.3 feet per second square. So take note, this is deceleration, therefore negative. So AA for acceleration and AD for deceleration. So if you would put this into its graph, so take note that at first seconds, so at 0 seconds, meron tayong rest. It is at rest. So therefore VI at 0 seconds is 0. And also your V at T F or the final velocity is equal to VF is equal to 0. Basically, nasa VI siya, at rest daw siya, and then it will accelerate on 0.6 feet per second. But at a time, so at a certain time, magde-decelerate yan. Pataas pa rin siya, but acceleration hanggang sa VF natin is equal to 0. So take note that this is a vertical translation, but particularly this is a rotational motion kasi yung elevator natin is a motor, run by a motor. So therefore rotational motion yan, na natatranslate yan in linear kinematics. So parang nag-rotational siya and then translate mo siya sa linear motion. So basically this is still acceleration, constant acceleration in one-dimensional motion in vertical translation. But take note, this is not a free fall, because when you are talking about free fall, you are not considering the air resistance and you are only considering the acceleration of gravity. Kaya nga free fall siya, di ba? Acceleration of your gravity. So in this case, you are considering the acceleration of your motor of the elevator. So elevator na lang. So take note that this is the specifications of your elevator. So your elevator has a specification of 0.6 feet per second acceleration and a deceleration of 0.3 feet per second and a maximum speed of 8 feet per second. So take note that this 8 feet per second is not necessary to meet. Take note that 8 feet per second is the maximum velocity of the elevator. Maximum velocity yan. Yan yung specs niya. Pag sinabing specs, hindi siya yung tawag ito. Pag sinabing maximum, hindi nahihigit dyan yung velocity na kayang ibigay ng elevator nyo. Which means that yung velocity ng elevator nyo is from 0 to 8 feet per second. So, kahit anong range dyan. Okay. So, mapapansin nyo that our body has two acceleration. So take note, this will be our datum or our ground, and this is our height, which is 48 feet. Take note that our body has two constant acceleration motion. So from 0 seconds up to T1. What is this T1? So lagay ko na lang T01. What is this T01? This is the time when the elevator will accelerate. And at that time, kung malapit na siya sa taas, syempre alangan naman na accelerate yan ng accelerate. Anong mangyayari? Pag accelerate yan ng accelerate, babanggayan, di ba? Babanggayan sa pader. So therefore, magde-decelerate siya at acceleration of 0.3 feet per second from T interval 1 to 2. Okay? Which is basically your VF is equal to 0. But there will be a certain VF here. Let's say this will be your VF1, which is unknown. And then your VF2 na to, yung 0. That is the final velocity. Ito yun. This is your final velocity at first interval. Ito yung final velocity nyo on the travel of the particle. So, let's say that your VI is equal to 0 kasi nga starting of at rest siya. Okay? So, at a certain point dito, sabihin natin dito, marireach siya yung VF1 natin. But what is our VF1? Our VF1, is it possible that you would use 8 feet per second? Actually, before reaching this 8 feet per second, let us, ano mangyayari pag na-reach yung 8 feet per second? Is it greater than 53? Is it less than 48? Ganun ba? So, take note that this 48 feet is the maximum height ng building. Yan yung hangganan ng building natin. So, therefore, itest natin itong 8 feet per second natin kung anong height siya marireach ng acceleration natin, which is 0.6 feet per second. So, using this formula, VF squared, so ilagay ko dito yung testing natin, no? Testing of given. So, would we use 8 feet per second as our VF1? So, let's see. So, let's say we have our formula VF squared less VI squared is equal to 2AD or 2AS. Okay, 2AS or D. Take note that at one directional motion na wala siyang direction, parehas lang yung S at yung direction at yung distance natin. Okay? So, take note that you have our VF1 and VF2. So, sakalang sinabi natin that letting our VF1, ito, equal to 8 feet per second square, what would be our S? So, let's say that substituting this value 8 feet, so 8 squared less our VI. Take note that we are starting from rest, so 0 yan, squared is equal to 2 multiplied by an acceleration of 0.6 multiplied by S. So, anong height ang marireach niya at a certain speed, at a certain velocity, acceleration of 0.6 until it reaches 8 feet. So, mapapansin mo, 8 squared divided by 2 times 0.6, you have an S equal to 53.33. Comparing, so comparison. Take note that your S is 53.33 if you would want to reach 8 feet per second. So, ang height lang natin is 48 feet. So, therefore, 53.33 exceeds 48 feet, which means that we will not use eight feet per second as our VF1. Kasi nga, mas mataas na siya sa building pag ginamit mo yun. Bago pa man niya ma-meet yung 8 feet per second na yan, lumampas na siya. Okay? So, therefore, we will take this VF as unknown. Okay? So as I have said, this 8 feet per second is the maximum speed of the elevator. Pero, it doesn't mean that you would meet that 8 feet per second. It just means that hindi na siya mag-exceed ng 8 feet per second. Yun lang yun. Hindi siya mag-exceed dito. Kasi yung specs niya hanggang dito lang. Okay? So, let us try to solve the problem then. The best solution or the best formula to be used is based on the question. So, the first question is determine the shortest time to make the leaf starting from rest and ending at rest. Okay. So, dalawang duration natin. So, this will be our total duration. Yung total time ng flight natin is the total duration. T total. Wherein, our T total will be defined as your T1, its acceleration, plus our T2, its deceleration until it will meet an 0 VF1. Okay? So, therefore, my time total will be equal to, I will put this T01 plus T12. So, take note that T01 is the time, T01 is the time interval at 0 to T01 or at acceleration pag mag-accelerate yung body natin. And then yung T12 natin is the time interval at deceleration pag magre-rest na yung body natin. Take note that our VF2 or your VF final is 0 from the word starting from rest and ending at rest. Yan. Yan yung mga clues natin. Okay? So, how will we solve this one? Basically, we will have two distances. Like our previous solution. So, may dalawa kasi nga dalawa yung time interval natin at dalawa yung constant acceleration natin from acceleration to deceleration. So, let's say this will be our D1 until VF1. Okay? This will be your D1. And then, or your S1. Okay? Well, kahit anong gusto nyo call dyan, basta ma-define natin siya as unknown variable. And then, this will be your D2. The remaining part. Oh, okay? This will be our D2. So, therefore, based on my diagram, I may also say that D1 plus my D2 is equal to 48 feet. Okay? Very easy, right? These are our first and second equations. Our second equation. This is our first equation. This is for getting the total time from starting to rest. So, this one is to give description to the two solutions in our graph. So, paano natin solve yan? Madali lang, di ba? Our D1 first. Solving for S1. So, take note, the best thing to do is to use this kinematic equation. Wala lang iba. So, we have, okay, you can also use the two other, but it would make the question more complicated in solving for the distance or your displacement or your position. So, we have VF squared less VA squared is equal to our 2AS. So, to a certain point D1, so let's say S is equal to D1, at S is equal to D1, so we'll have a value equal to VF squared is unknown. So, this will be our VF1 squared is unknown, less our VI. Note that our VI is equal to 0 because it is starting from rest, right? So, 0 equals 2 multiplied by our acceleration, nasa accelerating tayo, so which is 0.6 feet per second squared. So, dito tayo, solving for D1. Solving for D1. Okay, so we'll have a value equal to 0.6 feet per second squared multiplied by our D1. Okay, so we'll have our D1 is simply equal to VF1 squared all over 2 multiplied by 0.6 is equal to 1.2. Take note that our unit will be equal to, so VF squared, VF1 squared, so feet squared second squared divided by feet per second. So we'll have feet per second squared, so cancelling out one of your feet and cancelling out your seconds, so we have our D1 is equal to VF1 squared all over 1.2 multiplied by your feet, which has a unit of feet. Okay, so wag lang muna natin ilagay-lagay yung feet, so dindemonstrate ko lang para pakita sa inyo that if you know the units, hindi kayo mawawala. Next is our D2. Solving for our D2. Solving for D2. So, paano natin solve yung D2 natin? Okay. This will be our D2. Take note that our VF1 will be our VI at second time interval. Bakit? Basically, dyan ka lang galing eh. Tama? So, yun magiging VA1 mo, and then papunta sa VF4, which is 0. So, letting solving for D2 at second time interval, yung magde-decelerate na siya, at deceleration, wherein our acceleration is equal to negative 0.3 feet per second squared, and our VI will be equal to our VF1, which is also equal to unknown, and our VF will be equal to VF2, or your final velocity 2 is equal to 0 because of the word rest. Okay, so let's solve the problem. So we have VF squared less VI squared is equal to 2AS, letting our S will be S as your D2. Okay, so we have VF squared, which is 0 squared, less our VI, which is equal to, ano yung VI natin? Unknown, VF1. Okay, VF1 squared. Ito. Okay, which is equal to our 2 multiplied by negative 0.3 because of deceleration. 0.3 feet per second square. So, hindi ko na muna ilalagay yan para hindi malito. Multiplied by our S, which is considered as our D2. Okay, so we'll have a value equal to, cancelling out your negative sign because negative divided by negative is positive. So we have VF1 squared is equal to our 0.6 D2. Solving for our D2, we'll have a value equal to VF1 squared divided by 0.6 feet din to. Okay, this will be our D1 and D2. These are important solutions in the problem. So, substituting the value of your D1 and D2, substituting D1 and D2, substituting D1 and D2 to equation. Anong equation natin ito? So, our equation will be D1 plus D2 is equal to 48. Tama? Ito. Fit na yan. This equation. Right? So, we'll have a value equal to our D1, which is basically equal to VF1 squared all over 1.2 plus our D2, which is basically equal to VF1 squared all over 0.6, which is equal to our 48. Okay. So, mapapansin nyo that you can solve for your feet already. Feet per second. So, paano? Basically, lalabas lang natin yung VF1 squared natin. So, we have 1 all over 1.2 plus 1 all over 0.6 is equal to your 48. Okay? So, we'll have a value of your VF1 squared, which is equal to 48 divided by 1 all over 1.2 plus 1 all over 0.6. Okay? So, we'll have 48 divided by 1 all over 1.2 plus 1 all over 0.6. So, we'll have a value equal to 19.2. So, therefore, our VF1 will be equal to the square root of 19.2. Bakit natin square root? So, getting square root of both sides. Okay? Kaya, para mawala yung square natin, so, positive, negative yan, but basically positive yan. So, we'll have a value equal to square root of 19.2 is 4.3817806. This is feet per second. This will be our VF1, hindi siya 8. So take note that this 4.381 is in the range of our max speed, which is 8 feet per second. Okay? So therefore, your VF1 is already 4.3817,806. This is your VF1. So, anong ilalagay nyo sa LMS pag sakali? So, round this up. 4.38. Okay? Feet per second. To the nearest hundreds. Always yan. So, what is the main question? Determine the shortest time to lift to make the lift starting from rest and ending at rest. So let us solve for the shortest time. Okay. So we'll have a value of your T1 and T2. So this will be the shortest time by substituting the value of your VF. So paano? So solving for the time. Solving for the time. Solving for the time, so we'll have a value equal to T01 plus T12 equals total time, T total. But what is our T01? So to solve the T01, so take note that we have our first flight here. So we have solving for T01, so we have VF less VI is equal to 80, wherein our VF is equal to VF1. Solving for 201 at first time interval, so wherein we have our VF1 is equal to 4.38. So first time interval tayo, ito yun, first time interval sa D1. Okay, so we have our VI is 0 kasi guys starting from rest, so we have 4.38 which is equal to 0.6 multiplied by T. So our T01 is equal to 7.32, 7.3 kasi 0 to daw so round up po siya to the nearest 100, 7.30 seconds yan. So solving for T02, T12, solving for T12 is that you will have Vf less Vi is equal to 80. So at second time interval, at second time interval, wherein you will have a value of your Vf be equal to 0 kasi nga at rest yan, hihinto siya at rest, and your Vi will be equal to your Vf1, which is basically equal to our 4.38. So second interval na tayo. Pag sinabing second interval, ito yun, itong pababa na, okay, pababa na siya. And then pag sa free body diagram, ito yung nasa taas na palapit na siya sa tuktok, malapit na siya sa tuktok, ito, okay. So we have our interval T12, okay. So our Vf is equal to 0 kasi at rest less 4.38. Take note that its acceleration is equal to negative 0.3, tama. So we have negative 0.3 multiplied by T12. Therefore our T12 will basically equal to 4.38 divided by 0.3. So we have 14.6 seconds. So getting the total time is equal to T01 plus T12, which is equal to 7.3 plus 14.6, which is basically equal to 21.9 seconds. Okay, this is the formula explanation of this one. But particularly you can solve it using your calculus, differential calculus. But take note that based on the formula na define natin yung calculus nyo as ds over dt. Okay, to get the maximum and minimum value, so mag-derivative ka lang and set that value equal to 0. Okay, yan. Okay, so our final answer will be T1 is equal to 21.9. 90 yan. Lagay mo lang 0 kasi nga kailangan ko ng 2 decimal places. Okay, seconds.